8.5 should actually also be reviewed. We're going to be doing systems of equations with two variables, but it's going to build into 8.6, which is really our only new topic for the second half of Chapter 8. So, graphing and systems, and then we're going to deal with three variables, and that's new. But you have to understand two variable systems to be able to understand three variable, because the three are not very difficult. It just adds one step to the two. Okay? Well, for the two variable, there are three different methods. The first one is going to be graphing. The second one will be called substitution, and the third one is called elimination. So what will happen is, people will go, well, how do I know which one to use? Well, graphing I only use if they tell me to solve by graphing. Like, why do we have it? Well, it should help us actually make sense of our answers. That we can have some complicated looking equations, and the graphing makes the answer make sense. Okay, but generally, we don't solve the more complicated ones by graphing. We use the other two methods. And when we get into the other two methods, I'll tell you why we do which one. But for now, let's go ahead and graph this. To graph it, I need each equation in y equals mx plus b. Neither of these is in that form. So let's take our first equation, and let's get y equals. It wasn't too bad. We have y is equal to negative x plus 5. That is ready to graph. Second one's a little more work. I've got to move the 2x, just like I moved the x before. Do not combine those. But notice I'm not left with y this time. I'm left with negative y. And for some reason my x disappeared. Okay. So to get that to y equals, we have to divide everything by the negative 1. So that y is equal to positive 2x minus 4. Now we graph those. Our first equation starts at a y-intercept of 5. So 1, 2, 3, 4, 5. Plot a point. And from there, has a slope of negative 1 over 1. So down 1, right 1, down 1, right 1, down 1, right 1. I can go as far as we need to. Eventually, we're hoping we can see where these two lines will cross. The second one has a y-intercept of negative 4. So 0 and negative 1, 2, 3, negative 4. And it has a slope of 2 or 2 over 1. So we will go up to right 1, up to right 1, still haven't crossed, up to, there we go, we found that where they crossed. So these end up crossing at, looks like an x value of 3 and a y value of 2. Okay? So get them both in y equals mx plus b. Second, we graph them, starting at the y-intercept using the slope, we graph them. And the solution is what? The point where these two lines cross, the point they have in common. So make sure you write your answer as 3, 2. That point they have in common. Method 2. What if I took the same 2 and I said, I want to use substitution? I wouldn't, but if I wanted to, step 1, we either need an x equals or a y equals. We don't have that currently, do we? We don't have x equals or y equals. I could take the top equation, and I could move the x, though, and what would I get? Y is equal to negative x plus 5. We saw that last time. That is step 1. By the way, when do I use substitution? Because some of you are like, I would have never done that. Well, don't. I wouldn't for this one. I generally only use substitution if an x and a y are easy to get to, which they were this time, and it's already done. See, generally I don't use substitution unless I have an x equals or y equals already. This one didn't, so it wouldn't be my favorite method. What is step 2, though? Once that's done, we take this, what y is equal to, that negative x plus 5, and we substitute it into the other equation for y. Why can we do that? Because we just do this. People are like, I don't know, you just substitute it and you solve it. And I did it, my teacher gave me a gold star. Well, why can we do it? It has to do with method 1. So you remember, what was our solution? Like, I don't know, it's just a point. But not just any point. It was the point they had in common, where they have the same x and the same y. So if they're going to have the same x and the same y, then if y equals negative x plus 5 in the first equation, then I can go into the second equation, and in place of that y, I can put negative x plus 5, because they will have the same x and the same y. So I can make their y's equal, replace one with the other. What does this do for us? Well, I can distribute the negative first of all. Well, substitute and solve. So I can now solve this. 2x and x make 3x. Adding 5. Dividing by 3. All that hard work, that's now step 2. I feel like we've accomplished something. We're all done, right? No. See, this is not our solution. Remember, our solution is supposed to be the point they have in common. X equals 3 is not a point. I need to get the y value. And how? Step 3. I'm going to substitute this number into either equation and solve. Either equation. You're like, it doesn't matter? Well, no, because it should be what they have in common. So it could be 2x minus y equals 4. Or it could be, x plus y equals 5. And if I put that 3 in place of either of the x's, I will get the same answer. Now, out of these two, I like the one on the right. See, looking at that, I can go 3 plus what is 5? Hey, yeah, subtract 3, y is 2. Right? But would it be different if I plugged it into the other one? Well, it shouldn't. What is 2 times 3? 6 minus y equals 4. Negative y equals negative 2. Dividing by the negative 1. Y is equal to 2. I definitely think one of those was easier. But remember, it should be the same. If you leave your answer like this, I will be taking a quarter point off at the end. You're like, why? I got the answer. No, you didn't. Your answer is supposed to be a point. So to get full credit, make sure you list your answer as a point, x comma y, so 3 comma 2 is your answer. By the way, is that the same answer we got before? Oh, yes, it was. We also got 3, 2 by graphing, didn't we? This is 3 different ways of getting the same answer. When will I use graphing? Not unless they tell me, or unless I have technology and I'm wanting to show it off. When will I use substitution? Generally, if that's already done. If I have x equals or y equals, I'm going to use substitution. This one didn't have either really that I like, so I would encourage you to think about method 3, elimination. This one's actually primed for elimination. Some of you have been screaming at the screen for the last 8 minutes going, why don't you just combine these and cancel? Okay, let's talk about that. To do elimination or combinations, we have to change the equations. So we are going to multiply so that either the x or the y cancel. They have to be the same number but opposite. We already have that. We have a y and a negative y. So technically, step 1 is done for us. That's not going to happen too often, so don't get too excited. Step 2, since I have a variable that cancels, that is the same number but opposite, a positive 1 and a negative 1, we can add these. X plus 2x is 3x. Y minus y is 0 is equal to 9. Combine the equations and solve. Solve means I divide both sides now by 3, and I get x is 3. All done? No, that's not an answer, right? You don't get away from substituting, because what? You still have to take that answer and plug it in. Which equation? Does it matter? No, I'm going to do the first one because it's easiest and get that y is 2. Now am I done? No. Make sure you still write your answer as a point. So our point is what? 3 comma 2. Same answer. Out of all 3 of these this time, I believe that elimination was our easiest. It will not always be. But in this situation, for sure, this was the easiest method. But the key is what? That the answer doesn't change. Step 1 and 2 are the only different part, right? For eliminations or substitutions, steps 3 and 4 are identical. You have to write your answer as a point, and you have to take whatever answer you get first and substitute it in. So they're not that different, but when will I know which is which? Well, look at this one. Would you graph this? No, I'm not going to graph this unless they tell me to. Okay, and this isn't even ready to graph. Neither of these is y equals. I don't want to mess with that. So method 2 says substitution if we have x equals or y equals, do we? We sure do. So I would go with method 2, substitution, where I have the first step already done, x equals a number, or x equals y plus 2, and step 2 says take that y plus 2 and substitute it into the other equation for the x. So it becomes 2 times x, which is y plus 2, minus y equals 6. Solving this, we distribute the 2, 2y plus 4 minus y equals 6. Combine like terms, y plus 4 is 6, subtracting y is 2. All done? Don't do it, it's a trap, right? You still have to go back to step 3, which is to take that 2 and plug it in. Which equation is the easiest to solve for x? I'm going to say this one where it's x equals y plus 2, x equals 2 plus 2. We substituted that number in place of the y, so x equaled 4. By the way, did it matter which one? No. If I put it in the other one, you'll have to add the 2, 2x equals 8, divide by 2, x equals 4. You will get the same answer. Please do not forget, though, our last step is to write that answer as a point with an x value of 4 and a y value of 2. So when will I use method 2? When this is already done. If I already have x equals or y equals, use method 2. Looking at this one, do I already have an x equals or a y equals? No, I do not. I don't have an x or a y. I definitely don't want to graph these. This one would have a y-intercept of like freaking 1/5. Not fun. So I could technically take this top one and solve for the y. It wouldn't be too horrible, but no. This is definitely a method 3 question. Here's the problem with method 3 on this one. Currently those x's do not eliminate. Currently those y's do not eliminate. I need to have the same number but opposite. Neither of these is the same. 3 and 2 are not the same. 1 and 5 are not the same. But I do at least have y's that are opposite, see? So I'm going to focus on the y's, and I'm going to go, currently they're opposite. Could I make them the same number? Sure. I could change this 1 into a 5 by taking the top equation and multiplying it all by a 5. But keep in mind, it will distribute across the entire equation. So that makes that a 15x minus 5y and 50. The second one I didn't need to change. Can I solve this now? That was step 1. The y's will now eliminate. So I combine. Negative 5 plus 5 is 0. So how about 17x equals 51? That is combine and solve, dividing both sides by 17. How about x equals 3? Am I done? Step 3. Take that number and plug it into either of the equations, and we have to solve for y. Which y do I want to solve for? I understand that that's a 1 and this is a 5, but I prefer the positive, so I will do the bottom one. 2 times x plus 5y equals 1. 6 plus 5y equals 1. Subtracting the 6, 5y is equal to negative 5, and dividing y is equal to, for full credit, what is our answer? The point 3, negative 1. Could I have graphed these? Sure. I could have taken the top equation and got y is equal to 3x minus 10. The bottom one, y is equal to negative 2/5 x plus 1/5. Do I want to graph those by hand? No. But I could graph them in technology, and guess what? They would cross the point at 3, negative 1. We will have 3 options when I'm solving these. Algebraically, so far we've only seen the first thing where we have one solution. We get x equals a number and y equals a number. Graphically, if we graph them, that means they cross at a point. What if I eliminate all the x's and y's, all the variables disappear? We've seen this before. If I have a equals b, 2 equals 3, 5 equals 1, 1 equals 0, they're not going to ever be the same. This is no solution. Graphically, what does that mean? What does it mean if 2 lines never cross and they never have a point in common? That means we're dealing with parallel lines. And third, we will have infinite solutions. A equals a, 5 equals 5, 0 equals 0. What does that mean? Well, they are technically the same line, so they have infinite solutions. Okay? Scrolling down. This one, I do not have x equals or y equals. I don't want to have to graph it, so I'm going to use method 3, which means I'm going to make the x's or y's so they eliminate. I'm going to start with the smaller numbers. How about the y's again? None of these are opposite of each other, but I've got a 1 and a 3. I could change that negative 1 into a positive 3 by multiplying the entire top equation by a negative 3. That makes that a negative 6x, a positive 3y, and a negative 9. Remember, what was the goal? What was the purpose of this? Was to eliminate the y's. And will that happen? Will the y's eliminate this time? Ah, yes, they will. But that's weird, because this time, so do the x's, and so do the numbers. So what am I left with? What does this mean? Well, we've seen this before with equations. Actually means the same thing. This has infinite solutions. Like, how could that be true? How could these two have infinite solutions? Well, I'll show you. The first one is basically y equals, if I subtract the 2, how about 1/2 x? No, I'm messing that up. Sorry. If I subtract the 2, 2x minus 3. And on the second one, if I solve it, it's y equals 2x minus 3. They are the same line. If I were to graph 2x minus 3, what was it? 2. There's our first line. Y-intercept of negative 3 going up 2 over 1. And I graph another line at 2x minus 3. What just happened? They are literally the same line. So how many points do they have in common? Infinite. They are the same line. What the book will do is they will say it'll be any point. They'll put it in set notation. They'll say any point x comma y such that basically either of these equations is true. If it's on 2x minus y equals 3, any point on that is a solution. Okay? Next one. What method is this set up for? Well, I've got x equals. That is method 2. It amazes me to see how people mess around to try to just only stick with method 3. But look, I already have x equals. So I'm going to substitute that. That's method 2. That's substitution. So negative 2 times x. Let's see. Minus 6y equals 3. Distributing that. How about 6y minus 8 minus 6y equals 3. Combining like terms. Those zero out. I'm left with negative 8 equals 3. What does that mean? Well, the same as it did before. This has no solution. Graphically, what does this mean? Well, if I were to graph these two, the first one would be let's see, negative 1/3 x plus 4/3. Oh, that's pretty. The second one would be negative 1/3 x, and that would be minus 1/2. Okay. I'm not asking you to do this, but I want you to see why this works. Why does this have no solution? Well, negative 1/3 x plus 4/3. Negative, where are we at? Sorry. Negative 1/3 x, was it minus or plus? Plus 4/3. Oh, that's beautiful. My intercept of 4/3 going down 1/3. What's our next one? Negative 1/3 x minus 1/2. Negative 1/3 x minus 1/2. These two lines are what? Why does it matter that they're parallel? Remember, we're looking for the point these have in common. When will these ever cross? These two lines are parallel. They never cross. They are parallel. Therefore, they will have no solution. So basically, like I said, this is just an intro to stuff that you should have seen before. This is a review, but I need you to be strong at sections 8.4 and 8.5 because 8.6, it only adds one step to this. So if you can handle this, you are ready for 8.6. If not, get the work in and then get ready to start 8.6. It only adds one step.